In section 1.2, we'll look at how energy is transferred. So you'll look at the structure of trophic levels in the ecosystem, explain what happens to energy as it's transferred from one trophic level to another, look at energy or food webs and how the energy is transferred, and look at information to assess the effect of organism diversity on an endangered ecosystem if we have a chance to do that one. We know that there are a number of trophic levels that exist in ecosystems, and each one represents a level through which energy and matter are transferred. So again, that energy transfers from one trophic level to another. The first provides energy to fuel the rest of the levels. So it's always made up of producers. You always have to have your first trophic level being producers. The remaining levels are all going to be consumers. It just depends which type of consumers you have available to you from there. Decomposers could feed on any of those trophic levels, so whether it's on producers or consumers, it doesn't matter. Decomposers are available to get the energy from any level that they choose. The food chain is a model showing a linear pathway through which energy moves in an ecosystem. We generally see 3 to 6 trophic levels in a food chain. Food webs are more like a spider's web. There's lots of different connections between the food chains that are within them. There's a video link here that's a good one for you to check out as well, as far as the difference between the two goes. So here's a food chain on the left versus a food web on the right. So a food chain is linear. We move from one level to the next, to the next, to the next. Whereas with a food web, we could have multiple producers in this food web. So it's typically when you're looking at a whole ecosystem, we can have multiple primary consumers, secondary consumers, tertiary consumers. And so they can all feed off of each other or off of different levels. So there's lots of availability of energy there. And so you can see that they are intermixed rather than just having a single linear line. Another example of a food chain versus a food web. So we always start with producers, always, they're there at the bottom of our food chain. And as we move up the chain, we have our primary consumers, secondary consumers, tertiary consumers, and quaternary consumers. So we have an example of a terrestrial and a marine, both on the left. And another example of a food web, this is a terrestrial one. So again, decomposers at the bottom can feed on anything. But then we have our producers just above that that get their energy from the sun. And then we have consumers. So you can see the number 2 here. So the mouse is a consumer, and second level consumer, third trophic level with the snake, and so on. So the decomposers can get energy from all of these, whereas depending on which level they're at, they're getting their energy from the level below. When we're looking at the energy transfers in the trophic levels, we have typically very few trophic levels, like it said before, less than 5. The amount of energy transferred is between 10 and 20, or sorry, between 5 and 20. That's why we go with 10 as the rule of thumb. So remember that 10. Remaining energy is not passed on because it's stored in the tissues of the organism that is using that energy. So 90% of that is maintained by that organism, or released as heat, or released in other ways. But that 10% is what's available to the next level. Okay, so again, rule of 10. Keep that one in mind. Here's your first checkpoint in 1.2. We'll explain what a trophic level is, which trophic level or levels contain producers, and which ones are consumers. So your first trophic level would be your producers. Your second trophic level would be consumers. Your third trophic level would be secondary consumers, and so on. Why is less energy transferred from one trophic level to the next? And explain why there is a limit to the length of food chains. Ecological pyramids we'll discuss here. These represent the distribution of energy, and we have 3 different types. As well as the number of organisms in ecosystem. So here we go. We have a pyramid of biomass, a pyramid of numbers, and pyramid of energy. So each of the slides following goes into these in a little bit more detail here. So pyramid of biomass is how much biomass exists for each of these organisms in this trophic, or at each trophic level. Pyramid of numbers is how many of them actually exist. So we could have one oak tree and one hawk, but we could have many caterpillars and birds as well that are feeding off of this single producer here. Okay, so this is how many we have. The pyramid of numbers tells us the physical number of them. Pyramid of energy shows us what energy we have from one level to the next. So it will typically always look like this. because your producers are going to have the most energy. Your primary consumers are going to take 10% of that. Secondary consumers are going to take 10% from the primary consumers, and so on. So the energy does decrease as you go up the pyramid of energy. So here's our pyramid of numbers first. This represents the number of organisms that are at each trophic level. So you could see that there might only be one at the top, one at the bottom, and multiple in the middle. Each bar represents a different trophic level, and the width represents relative number of organisms at that level. So how big that the width of the pyramid at that level is tells us the relative number of organisms. Pyramids can also be inverted depending on the situation. As I showed you before, it's the exact same one, just a little bit different. This inversion occurs when we have a large number of primary consumers feeding on just one single producer. Pyramid of biomass. So the biomass is the dry mass of living organisms per unit of area. So typically, we have the biomass that indicates how much is present at each trophic level. So we have the primary producers in this one. So this is a hypothetical ocean biomass pyramid. So we have phytoplankton here. We could have a million kilograms of phytoplankton. For our herbivores or zooplankton, we could have 100,000 kilograms. Lower level carnivores, such as shrimp, could be at 10,000 kilograms. Mid level carnivores at 1,000, whereas our very top carnivore, the shark, could be at 100 kilograms. So it's the actual overall mass that exists in that pyramid. These pyramids could also be inverted. The ocean systems may show an inverted pyramid as the producers make up much less biomass than what could feed on them. So here's with the phytoplankton and zooplankton. So zooplankton feed off of the phytoplankton, photosynthesis, that gives you a clue there. Their overall mass is much smaller than what we get from the zooplankton. Even though we could have many, many more of them in the numbers, their mass is much smaller. And so they transfer a larger amount of energy to the zooplankton per kilogram of mass. So looking at two different biomass pyramids. So this was the example that I just showed you, and this was one on the previous slide. So for example, it could be from the English Channel. So water again, we're looking at body of water. The primary producers, the biomass is much smaller than the primary consumers. Whereas if we look at somewhere else, like a bog in Florida, our primary producers have a much larger biomass than the primary consumers, secondary consumers, and tertiary consumers. So they could look like either of these when you're looking at biomass pyramids. Disadvantages: inverted pyramids lose their ability to accurately represent how energy is being transferred from one level to the next. So we see that there's energy being transferred. We know that that's happening typically at that 10% rule, but it's really challenging to see when the pyramids are inverted that that's actually happening. Finally, our pyramid of energy. This is the total amount of energy that's transferred through each trophic level. So when we're looking at trophic levels, this is number 1 trophic level, 2nd trophic level, 3rd trophic level, 4th and 5th trophic levels. And then this is the type of organism that exists at each level. Pyramids of energy are always going to be upright because energy can only be transferred to the next level or to decomposers, but that's not typically something that we see much in these pyramids of energy. Okay, so this will never happen as a pyramid of energy. This one here makes more sense for a pyramid of energy if I think they're taking less than 10% here, maybe about 5 to 10%, depending on the level as it's moving up. And so pyramid of energy may match the pyramid of numbers, but not always. Disadvantages for pyramids of energy. To develop one, we must know how much energy is contained in the tissues at each trophic level. So we have to use calorimetry, which can be quite a process. We need a sample of material and we burn that to determine how much energy it contains. So again, time consuming to actually determine the value for pyramids of energy. Here's your next checkpoint. Explain why a pyramid of numbers can be upright or inverted, and describe 2 ways that a pyramid of energy is different from a pyramid of numbers and a pyramid of biomass. So just comparing them so that you can demonstrate your understanding there. Make sure that you're checking it and knowing what's going on with those. There are 3 videos here that go over these different types of pyramids. They are helpful if you're looking for some additional information on those. As we move through energy and transfer of energy transfer and the stability of the ecosystems. We're just finishing up here with chapter 1. As our climate changes, so does the distribution of organisms in our ecosystem. If organisms at the bottom of our pyramids are affected, then all those changes and those challenges ripple up to the levels above them. So if we have fewer or less varied producers, then the food webs will change. We can get a more fragile ecosystem as a result. So it's really important that we're doing what we can to help maintain our ecosystems so that us as consumers have the energy available to us so that we can continue on. 1.2 review is on page 27, chapter 1 reviews, page 30 and 31, if you want to take a look at those to just verify your understanding of the material covered in this chapter.